Okay, welcome everyone to our spotlight session on finance and economics, the third of 3 hackathons for the Generative AI Innovation Incubator. We have an exciting lineup for you today. So first of all, you will probably want to check out our team websites. You can find them on GitHub. And as soon as I am not sharing my screen, I will go ahead and copy these links into the chat so that you'll be able to get to those. So I'm Carolyn Rose, and I'm doing the open and welcome. We will have a sneak peek from each of our hackathon teams, 3 minutes per team. And then we will have 3 spotlight talks, a 10-minute talk from one of our GAI3 interns, Anusha Rao, and an undergraduate intern, Siddharth Parekh. They're going to be talking about some of the great work they've been doing recently in the area of finance and large language models. And then we have 2 faculty spotlight talks, one from Tianqi Chen and Norman Sadeh. And we're very excited to have them here. And I think that they will be very inspiring and mature views of AI from all of the work that they have been doing. So with that, I will very soon turn it over to our teams, but I want to make a couple of announcements. One of them is that tomorrow will be the judging event for our teams. So today you get to see a sneak peek. But tomorrow, you can actually weigh in on the judging of the final projects. So the teams will be working very hard for the rest of the day and tomorrow morning. And then they'll be presenting their progress and what they've learned. And in some ways, I think the lessons learned are the most valuable contribution to the community as part of our ongoing discussions in the GAI3. And then there will be a deliberation of judges. And so some expert judges will vote alongside of the average of the whole community vote that counts as one person. And then a winning team will be selected and announced. Then next Friday will be the closing event of our summer series. We'll have a closing keynote by Jamie Teven from Microsoft. Then we'll have the presentation from each of the 3 winning teams, one from each hackathon. And then our closing keynote will be from Mona Diab, who's the new LTI department head. So I started out this summer series as the interim department head of LTI, and now I'm very happy to have stepped down from that and welcomed in our new department head, Mona Diab. But GAI3 will continue. We plan to have a monthly online talk series and other kinds of things. There will be a small break in the beginning of fall, but then we'll be kicking off again. I'll finish off this session with a few more announcements, but for now, I think we will start with our team presentations. And the first team that we'll be presenting now is Chat BI. Chat BI, can you go ahead and share your screen? Okay, and you have 3 minutes, and I'm starting the timer now.
Hello, everybody. This is Sang Venkatraman, and I'm presenting for Chat BI. And at Chat BI, we believe outcomes is a combination of insights and automations. The problem we are trying to solve, and this is our team. We are a team of 4 with a background in data science and engineering. Businesses don't want more data. They want outcomes. And business intelligence tools today enable reporting, which is a great first step. But what we are really looking to enable with generative AI is the few insights and action items that the business needs to focus on today or this month or this quarter to truly move their business forward. Where it makes sense, we want to enable Q&A capabilities. We want to bring together data, and we want to empower users with the ability to take actions and automate workflows. So our solution, we are a vertically integrated insights and automation product, and we are focused on small and medium-sized businesses to begin with. Why this customer focus? We care about technology, but we care more about our customers. Small and medium-sized businesses are often ignored when it comes to getting the latest tech, so we want to change that. And we also believe that by empowering SMBs, we can empower the whole economy because it's got a very strong effect there. And why generative AI? We believe that businesses at different scale need different kinds of insights and automations. Having generic SQL-based dashboards just don't work for everybody. And AI has the ability to bring in human when needed, but automate workflows. And we think we can take this close to the place where Gen AI is the brain of the business. This is a user persona. This is Tom Jeffs, who runs a business with his wife, Janice. And they own a general contractor business, and they have 12 subcontractors. They have slightly different usage patterns. Janice handles all the business side of it. Tom is on the field. So our proposition is we need insights to be as simple as this, jobs, number of contractors that are busy, ability to increase revenue, etc. So, these are some of the examples of our insights. You have 3 jobs. This is an operational insight. You can have a revenue insight. We can have a cash flow insight, and we can have opportunities. And we can add more. But the whole point is give them exactly what they need to see, enable them a way to act on it and move forward. That was, and then the proof points is, so Shopify recently launched Sidekick AI, which is an AI assistant for e-commerce business owners. Microsoft Power BI now has insights baked into their platform for beta. What's unique about us? We are tech-enabled, but we are focused on verticals and customers. And we believe that by fine-tuning our model and keeping the UX really simple, we can meet our user needs. So
thank you very much. That was great. Okay, and now we will have our second presentation. So I will call up Sustainable Investor AI.
Thank you, Carolyn.
Great.
All right, so hi folks, my name is Anshul Madan. We are Team Sustainable Investor AI. These are my teammates. So we are building an AI advisor for investors with a focus on environmental, social, and governance investments by combining analysis across traditional financial factors, revenue growth, profitability, and sustainability metrics, example, carbon footprint and social impact. 86% of millennials indicate they consider ESG as an important investment criteria, and investors recognize the impact of environmental and social risks on financial performance, as can be seen by the quantity of global assets managed according to sustainability investment strategies. Investors value sustainability information but complain about data quality, greenwashing, which is the use of misleading labels and advertising to create just an illusion of environmental responsibilities. And another thing they complain about is the consistency and reliability. Financial research is time-consuming and labor-intensive, as the volume and complexity of data presents significant challenges for manual analysis. So our solution is to build a reliable investment advisor for ESG investments by providing financial advice in a natural language interface, along with the measurement of the trustworthiness. By making it easy to analyze reports and detect greenwashing, we are helping the users make informed investment decisions. Our end goal is to leverage AI to summarize entire financial research, including 10Ks, but our focus for the hackathon is sustainability reports. Come back tomorrow for the final presentation, and my colleague Aijan is going to talk about how we use standards to detect greenwashing. Here are some results so far. It is important to choose the LLM model per the use case. We chose Claude 2 because of its 100K token limit and support for large sustainability reports, which we are using for analyzing, thus obviating the need for external long-term memory like vector databases. We also realized the need for prompt guidelines to accurately quantify trustability of data sources. Referring to the standards, we are developing detailed questions, sub-questions, to get clarity on the requirement and quantify trustability. And for reliable analysis of the reports, we do not simply pass the user questions through the prompt. We need to develop pre-prompts to specify how the responses need to adhere to the standards as per the requirements. Example, only use metrics defined in the standards and not companies' self-defined vague metrics. We also have some other planned results, like measuring effectiveness using prompt guidelines and different prompting strategies, example, few-shot prompting. I look forward to see you at our session tomorrow. Thank you.
Great. Thanks so much, Anshul. Okay, and now our next team is TrustSense.
Right, just a second, and just share my screen.
Okay, and go ahead and get started.
Hello, everyone. So our team is Trust Sons. My name is Kaushik, and we have Sai, Pranava, Jahan, Ian, James in our team, everyone from different disciplines. To give you again a little background, a recap, cybercrime has become a very big problem and it's getting a lot worse. A cyber attack occurs roughly once every 39 seconds, and more than 800,000 people have fallen victim to these cyber attacks each year. And to give you an example of how generative AI can aid these attackers in crafting convincing phishing emails to scam someone or create fraudulent emails related to finance. Here is an example when we asked ChatGPT to generate such an email, and also it'll give different techniques that are used by these people to create these malicious content. And this is an overview of our solution, what we are trying to build for this hackathon. So mostly our novelty here is the explainability module that we are using in our architecture, which explains the decision taken by the trained model. It will tell why the model had to take such a decision, whether it is fake or real. And we are also generating a report which will allow users to take a decision or on what extent they could trust the decision made by the model. And we are focusing on identifying the trust and sincerity level of information that is encountered online by the users. We analyze message content, tone, style, and also other data, and detect potential vectors of attacks and help users make informed decisions. So far, we were able to create synthetic data using ChatGPT, and also we found some data sets online which are kind of relevant to what we are working on, related to fraudulent and phishing emails and also Twitter bot data. And we also began testing LLM based models. Right now we are playing with Llama 1. We were able to, right now we are doing it more in a zero shot way by just using prompts and seeing if it is able to detect it on its own. We would also like to fine tune the model, and we also will be building this Google Chrome extension that we talked about, which will make the tool more accessible to the end users. Yeah, thank you.
Thank you so much. Okay, and our next team is Taxman.
Hey guys, 1 second. Let me share the screen. Hey guys, we're Team Taxman. We're Abdullah, Mihir, me, and Hanif, based across Pittsburgh, across all my major disciplines. And we are working on the issue of taxes, something which everyone is pretty knowledgeable about, but most of the times they are unsure as to what happens, how it works out. And first is we're trying to understand if it's a pertinent problem. So advent of AI or generative AI in the field of taxes has fueled a lot of faster and better tax experience for taxpayers, and we want to fit in one of those aspects of how you can help, how you can get help from generative AI in trying to understand lexicon about taxes, and in general how to fill out forms which are related to specific taxes. Our solution is an easy to use platform for filing taxes and filling out forms. Specifically for the duration of hackathon, we are focusing on form 1040, and the tool will help you understand tax lexicon, terminology, and some of these really weird terms which most of the people don't understand. For example, unattributed income from other sources. I could never understand what it is. The genesis of that idea came from me last semester in spring, trying to really struggle in understanding how these things work. And if I could have had one help, because I ended up Googling almost everything on the platform or on the forum itself. So our tool will help us understand, will help you understand some of the terms which are not, which are pretty common in the tax forms, which you might not know, and it will take an input, for example, your form W2, and fill in the tax details for you. How are we trying to do this? So it's based on 3 main interfaces. One is Llama, a fine-tuned large language model, which will help you navigate through form W2. The other is OCR, which is called as optical character recognition. It's just a way in which computer reads text and it generates information from it. And all of it is combined in an easy to use UI for any time while filling the form. If you are unsure about anything, what does capital gains means? How do I use that? The tool will help you in understanding that and then point towards the place where you might be able to get that information. And what would be the next steps essentially then after the hackathon? Like we mentioned, we processed form W2 in the 1040. So 1040 in itself contains more than 50 forms and schedules, all of which are listed in a complete tax code. Our next steps would be to incorporate all of those forms so that it reaches a point where you can just upload stuff onto the platform and it fills it out for you. Another step would be tuning the OCR model so that it can identify information for filling out the form correctly. And then understand this is just being done for one category, which is individual. Individual income tax forms one subdivision, and like this, there exists 10 more categories which fall under individual. And then similarly, there exists a completely different category for business, which is a corporate business tax. So the next logical steps.
I'm going to have to cut you off now. But thank you so much.
Yeah, thank you.
Okay, and the final team is Team Aita. Are you ready with your presentation?
Yeah, sure. Okay.
Okay, and go ahead and start.
Sounds good. Hi everyone. We are Team Project ITA, and let's go ahead. So this is who we are. I'm Hao. I'm currently a software engineer at JP Morgan. Worked at firm before, graduated from CMU on 2016. And we also have Fangfeng. She's currently a risk manager at Morgan Funding, ex-PayPal, and graduated from Duke. And we also have ZJ. He's currently an engineering manager at PayPal. He got a PhD from Ohio State University. So what we are working on is when you leveraging AI or most generative AI to automate the data pipelines. So we call it like ETL process. So basically, data engineering is a really cost subsidiary of like the company's whole budgets. So we want to reduce it as much as possible to automate the data onboarding, ingestion, and migration process. We're also going to stretch it to leverage AI for the testing, validations, monitoring, observing the data to ensure the safety of the pipelines. So basically, the core idea in this hackathon is we want to automate the process with Snowflake. So something like a user input data, like, hi, can you pull the transaction data and show the top 10 merchants? Or can you run this query on Snowflake? Or can you give me some like database or table example for me? So your agent can turn this prompt into instructions and execute this task and call the external Snowflake API. And then it will return the result to the user. So this is like a typical flow. We have front end, back end. We're also working on fine tuning the model served on the back end language chain and to give a better user experience toward like model hallucinations. And yeah, I want to give maybe like a quick short demo what we are having now. So I put up this like a basic UI, and then I could say, hey, connect to Snowflake. So the agent will try to connect to the Snowflake. Oh, it's set like, hey, it's connected. And I can ask what database do I have in Snowflake? So it can look into the information you really need with like this prompt. It find like 4 or 5 like demo databases, and I can also ask what schemas.
Okay, Hao. I'm going to have to cut you off now, but thank you so much. And it's very impressive that you have a demo already. Thank you. So those were our teams. And now we will have a spotlight talk, a short spotlight talk from interns Anusha Rao and Siddharth Parekh. Please go right ahead.
Yeah, is my screen visible?
Yes, please go ahead.
So hi everyone, I'm Anusha Rao, a graduate student at CNU. I am currently pursuing my master's in computational data science, and my teammate is Siddharth Parekh, an undergraduate student at CNU. So together we present our work on FinQA that tests the numerical reasoning capabilities in large language models. So as we all know that there has been a considerable excitement within the community regarding—
Anusha, your slide didn't, your slide, oh, there, sorry, there's just a lag. Please go ahead.
Okay, yeah. There's been a considerable excitement in the community regarding large language models and their potential achievements. ChatGPT has now become a new standard, and with the release of GPT-4, it has marked the pinnacle of innovation in natural language processing. But however, we should ask ourselves two important questions. One among them is that open source models like Llama have comparable results with that of OpenAI models. And the second one is that is few-shot prompting a viable solution for enhancing all capabilities in large language models? So let's answer these questions through our experiments on exploring numerical reasoning capabilities in LLMs. So as intelligence continues to advance, there's definitely a need to establish more robust benchmarks. And one such benchmark is FinQA that is designed particularly for finance. So a typical FinQA examples looks as follows. It consists of a corpus that has both textual and tabular information. It has a question that needs to be fed into the model, and it also expects a quantitative answer that can be derived using a series of operations. So we tried out zero-shot chain of thought prompting on GPT 3.5. While the model successfully extracted the details from the text, it struggled to understand the underlying language. That is, in this particular case, it did not understand the meaning of weighted average. So the operations it carried out did not lead out to a successful answer. So in addition to this, the model also failed to capture the details outlined in the table because of the extensive length of text. So what exactly was the problem here? Why is that financial data harder than normal text? So unlike regular textual data, financial data mostly comprises of numbers, and then it involves computation from tabular content. So a recent study revealed that current word embeddings treat numbers as ordinary words, and this results in models capturing a rough sense of the magnitude, but they fail to grasp exact numerical significance. So therefore, we need to design an intricate architecture that would help us understand the context better. Let's now look at our architecture. So the FinQA dataset comprises of approximately 8,000 question answer pairs. So we will feed in the corpus along with the question into the retriever model. This consists of the MPNet based model, which I'll be talking about later in detail. And then we use cosine similarity to extract top n most important sentences, in our case, top 5, that will be fed into the generator as input. So the generator is a Code T5 plus model, which we'll be talking about in detail. This generates a domain-specific language to solve the problem, and then this is evaluated to produce a mathematical output as the answer. So let's delve deeper into the retriever architecture now. With my initial experiments, I started with Llama 1. I started fine-tuning the 7 billion model initially, and then went on up to 30 billion model. However, this pipeline did not really give me the expected output. It did not enhance the results from baseline FinQA model. So I searched for a model which was particularly designed for retrieval. And I found MPNet based to be the most appropriate one. The uniqueness of this model was that the model solves the problems with both masked language modeling and permuted language modeling. So it introduces dependency among predicted tokens, that's solving MLM's problem in BERT. On the other hand, it also overcomes position discrepancy by incorporating auxiliary position information, which solves the PLM's problem in XLNet. So here are the fine-tuned results that we obtained from our retriever. Comparing it to the gold index results, we see that 2 out of the 3 sentences that we retrieved are important for our generation, and hence we obtained the accuracy of 89.73% while retrieving top 3 results and 93.5% while retrieving top 5 results.
Yeah. Moving on to the generator. So once we receive the outputs from the retriever, we encode them using a pre-trained encoder. In our case, we're using Code T5+, which was quite recently released, along with the embeddings for the special tokens from the domain-specific language, which is the operations, and then the parentheses, and so on. We then pass these on to a custom LSTM decoder, which at each time step generates a part of the program, and it updates the memory to include an evaluation of the previous step until a complete program is generated. Has the slide changed for everyone? Okay, yeah. With respect to the results, so we have two metrics that we evaluate this on. Program accuracy and execution accuracy. So execution accuracy is more lenient and allows for different programs that might reach the same answer by chance, or there is some alternative form of the program, whereas program accuracy checks for whether the generated program is identical to the target program. So having trained two models, one on the results we obtained from the retriever, and another on the golden retrievals from the FinQA dataset, we see that in both cases, we've beat general crowd performance by a significant margin. But at the same time, we're also quite far from expert performance, which is likely the result of knowledge gained from being in the field for years. Clearly, we need further research into this. An alternative approach that we are currently testing is, instead of using an LSTM decoder, we use Code T5+ as a complete text-to-text generator, which would hopefully take advantage of the model's code generation and understanding capabilities, since it's trained on a corpus containing largely of just code.
So now let's compare our results with GPT 3.5. We chose a sample of 25 sentences that were representative enough of the corpus. And we found that GPT 3.5 without chain of thought prompting gives us approximately 48%. And with chain of thought prompting, that is asking the model to generate a step-by-step upon giving a wrong answer, the model achieves 56% accuracy, which is definitely an improvement. And finally, our FinQA model that we designed achieved 72% of the 72% accuracy, beating all of the ChatGPT or GPT 3.5 models. This signifies that there is definitely a need to have a complex architecture which has better understanding of the domain than prompting. We've made a couple of observations throughout our experiments, and here are a few of them. The first one was that most of the successful operations are related to average, net change, or growth rate. The second one was that changing the word from portion to percentage does give us improvements. So this shows that the model is aware of certain kinds of popularly used words, but it fails when we use a synonym of that word which is not so commonly used. Another strange yet interesting in observation was that when we use the word cash, it seems to have confused the model. This might be because financial texts don't really depend on the mode of payment, and this does not really change the answer, but this seems to have affected the model in some way. And finally, despite all our efforts, domain-specific words like debt commons or capital expenditure are still hard for the model to learn. These are the terms which are learned by financial professionals over time and are rarely explained in financial corpus as well. That is why our model is not able to perform that well on these words. So finally, this leaves us some room of improvement for our future works. And while our experiments with Llama 1 didn't turn out to be expected, we feel that Llama 2 is much more popular because we've tried out zero-shot prompting and few-shot prompting techniques, and it was promising than Llama 1. And hence, we would want to try this out. And in addition to that, a paper by Armina Nurbaksh under Professor Rose has introduce a novel addition to the generator architecture, which adjusts the attention weights of the model based on the alignment of input to that of the output. So we believe that combining these two architectures will help us attain significant improvement. So that is what we'll be trying out as our future steps. So that's it from our side. Thank you.
Thank you so much. That was very inspiring. And now we will have our first faculty spotlight talk by Tianqi Chen.
Can everybody see the slides? Yes.
Yes, go right ahead.
Yeah, thank you for inviting me. So, hello everyone. Today I'm going to tell you a bit about the works that we're doing on applying machine learning compilations and bringing open language models onto consumer devices. And to give a background, one of the things we're looking at is software landscape changing from traditional software to AI. Right? In the case of AIs, we have the need of bringing larger data sets, bigger models, and more compute. And there's a question about how do we develop software ecosystem around this kind of new paradigm. And among them, one of the key challenges here is how we do ML system optimization. So while we can go and directly call APIs, there's a lot of questions on how you really run those machine learning models onto each environment. Some of them include things like data center CPUs, GPUs, and special accelerators. Traditionally, what people do is engineers in different hardware backends really go and build libraries. And it's really hard for us to be able to generalize and support that a broader spectrum of devices that's out there. So one of the things that our group have been working on is this area called machine learning compilation. So the goal is to be able to take machine learning models and automatically generate code for the hardware of interest. In this case, the hardware could be it runs on your phones, runs on your browsers, and runs on your laptop. Sometimes some of them also runs on data center devices. So specifically, one of the things a technology I've been developing on recently is called TVM Unity. So this is an open source machine learning compiler that allows you to be able to bring high-level machine learning models onto any of the environments you're interested in. And so TVM Unity is more like a Python-focused thing that allows you to build a set of ML programs in a centralized abstraction called IR module, where each of the components here can be visualized in Python and allows you to be able to correspond to some of the components. For example, in this case, this Sybil diffusion model, and you have a VAE decoder that's correspond to the executions. And of course, one of the key themes in those end-to-end machine learning execution is that nowadays that's critical to support what we call dynamic shape or symbolic shape, so that you will be able to support things like variable lengths in natural languages and different kind of input size in here. So with IR module central concept, what TVM offers is a unified API that allows you to productively import models from existing machine learning models like PyTorch, be able to inspect and interact with the corresponding programs. You can go and transform them and bring it more powerful, making it run on more devices, and then you can deploy it onto the environment of choice. So one of the key features that we have been pushing for is what we call universal deployment. That means that you write your code and bring it into the compilation flow. And we'll be able to build a runnable function that you can go and take it and deploy onto environment of interest. That could mean Python, Torch environment, C++, or in certain cases, we can also directly deploy to the browser and call the JavaScript through a runtime that we support. So this like high-level background, I'm going to tell you a bit about what we can do with this kind of technology. One specific things we're looking at is how we can bring in foundational models onto consumer devices. So there's a blog post that you can go and check out. There are a lot of motivations on why you want to deploy your large language models onto not only the service providers, but also deploy them onto local devices like your laptop or phone. For example, one of the motivations, you can certainly bring more personalization so that you can bring models that interact with personal data. Sometimes you're on a flight or you are off the grid and you still want to be able to have your personal assistant with you. If you're developing gamings, maybe you want to be able to have some specialized models that runs on the game and you don't want to query the internet all the time. And finally, there's an interesting future about if we can bring decentralized devices that are working with each other, how would that look like versus the centralized vision? So in order to do that, we will need to be able to deploy those models onto a large number of consumer devices. And you can see all the images here, right? That includes your laptop, your game consoles like a Steam Deck and Switch, mobile devices like iPhone or Android devices, and so on. The challenge here is that there's so many kind of ways to program those devices. So I'm listing possible GPU runtimes here, and if you count, you can find there are at least 9 here that correspond to all those environments. And it's really, it's also very hard to keep up with those machine learning model and system development. So what we do is that we bring in this ML compilation technology and takes the language model and stable diffusion models and apply some of optimizations we talked about in the beginning, and that allows us to bring those models onto the environment of interest. So these are like a high-level technologies, and if you're interested, you can see it in action. So if you go to this link here, mlc.ai, mlc.m, you will be able to find standalone models that you can run on Windows, Linux, your MacBook, locally or local, no server support. For example, if you have an M2 device, actually we do have a version that allows you to run Llama 2, the biggest version, 17 billion, on latest M2 MacBook. Of course, in that case, we will need a 64 gigabytes RAM, but it's really amazing that you can run such a bigger model on kind of a local device you have, and think about what kind of future it can enable. Another fun thing we do is we are building an iPhone app that allows you to bring, in this case, a 7 billion model of Llama directly onto your phone. So it is already available on App Store. So if you go to the link and download it, you can go and try it out. You will be able to try with a Llama 2 model, a Red Pajama model in a quite decent speed. In this case, it's writing a poem for CMU. You can see, it's doing pretty well. And we also have an Android version that does a similar thing. So in this case, really bring it to a wide variety of platforms that are interested in. Finally, one of the things we are doing is we are bringing it to the browser. So in this case, there's a recent technology called Web GPU that allows you to directly run GPUs through this is a browser client side. So there's no server involved. You just load a web page and you chat with the chatbot. And this is a package of web LLM. So if you're interested in building local language model applications, you can install npm package and build JavaScript applications around. And actually in this case, we are also able to run very big Llama models depending on the local GPU that you have. So besides language models, we also have other things like stable diffusion. You will be able to run the stable diffusion directly in a browser in a very effective way. Okay, so that's the end of the talk. And if you are interested in learning more about machine learning compilation, we have a website, including related courses, materials, and all the open source projects you can participate. Yeah.
Thank you so much. We can take a few questions. Are there questions from the audience? You can either raise your hand in Zoom or put it in the chat. We have a sort of congratulatory note in the chat, and then a question. Can you speak more about Web GPU?
Yeah, so Web GPU is this latest technology that allows you to access GPU on your local laptops through JavaScript and browser. So if you're familiar with WebGL before, there's a previous generation of technology. So in this case, effectively, you're accessing a local GPU instead of running GPU on a server. So it's a client-side technology, and the Chrome just shipped it officially, I think, a few months ago. So officially, if you are using a Chrome, you just need to go and open a web page. It should be able to help you to run on the local device. That's a question of why is ML compilation helpful, right? So first of all, you'll find that there's so many GPU backend. You don't want to build accelerated software for each of them. So ML compilation helps you to be able to target all those backend that you see today. It also gives you more optimization. So effectively, if you want to get the best performance or most of memory out of it, then it will get you better performance than some of the other alternatives. Yeah.
There's another question in the chat. What are the career opportunities in this space for someone with a background in product design who doesn't code?
Yeah, so that's a great question, right? So I think one of the things that we can think about is imagine a future, right? There are different futures from today. Like one possible future could be, you run all the large language generative AI models from the big players, right? in the cloud. Another possible future could be, there will be personal assistant that runs locally together with the cloud. And there are questions about how do you enable privacy, how do you enable personalizations, and think about, what technology can enable is really interesting. Yeah.
Yeah, that's really exciting. Okay, other questions? I have one question, and that is, so it's very interesting that you have your these phone apps, and a lot of people are working on how can you compress down models so they could actually run on your phone locally. What do you see as the trade-offs in that space? Do you think, like, where do you think you would put your money?
Yeah, so for example, right now we do need to do heavy quantization. So for example, in order to run the app on iPhone, right, you need to fit everything into 4 GB of RAM. So that's a hard limit, and in this case, we have to quantize it to 3-bit, which kind of is kind of a lossy compression. I think it's still a very active field to work on, and we are also building a foundational tool so that, for example, if you are working on a new model or compression algorithms, you will be able to plug it in onto our framework, and you will be able to run the model on the phone. Yeah.
Yeah, there's a comment in the chat about the trade-offs might be different in developing countries where the internet connectivity is not so great. Is there one more question, or should we move on to the next talk? I'm not seeing another question. Thank you so much, Tianqi Chen. And I'm so sorry for saying your name wrong earlier. That was my oversight. But thank you so much. This was very interesting and inspiring. And now, last but absolutely not least, we're very excited to have our second faculty spotlight talk by Norman Sadeh.
Well, thank you, Carolyn. And I think there's a nice transition here from Tianqi's talk to my talk on privacy. As he pointed out, one reason for trying to build these models on cell phones has to do actually with privacy issues. But historically, as you probably also realize, privacy has often been looked at as an afterthought and perhaps also an annoyance by the AI community. And so what I'm going to do in this talk is I'm going to attempt to first explain why privacy matters and what is privacy. And I'll talk about my research within this area, including how we have been using AI, including generative AI, to enhance privacy. And along the way, we'll talk about why privacy is challenging. So that's what I hope to do over the next few minutes. I'm not quite sure how much time I have, Caroline, but I was told about 20 minutes. So I'm going to try to stick to that if I can.
Yes, you have 20 minutes.
So when I have more time, I like to walk people through scenarios that require them to think about the information they might have to provide to insurance companies as they go shopping for insurance policies for their new car. We don't have the time to do that, but I'll briefly summarize what typically comes out. And I've probably done this about 100 times over the past 15 years. I pretty much always ask the same questions. This is just a subset of those questions. But I ask people about disclosing how fast they drive, self-reported disclosures, but also discuss the possibility of them installing a GPS unit that's going to be reporting their speed to their insurance company, or using apps on their smartphones to do exactly the same thing. And the kinds of answers that you get vary a lot from one group of people to another. And obviously, they vary also based on the way in which that data is going to be collected, for instance, whether it's self-reported or using sensors. And I also go on and ask people about sharing how much, how well they sleep, for instance, at night, which, as you probably realize, is often correlated also with the likelihood that you might crash. And I ask them, about scenarios where this is self-reported, but also, as you probably realize, with your smartwatch, your smartphone, and even sensors that these days can be embedded in your bed or your bed sheets. I ask them how they feel about those scenarios. And those are, typical types of statistics, although there's quite a bit of variation from one group of people to another. And the reason why I walk people through that is to make a few different points. And those points include, number one, not everybody feels the same way about these scenarios. So you get actually quite a bit of variety in terms of answers. But I always point out, and I've done this at least 100 times, there's never been one time where a single individual in the audience has indicated that they were willing to share all the information that was contemplated in these scenarios. And so the point here is that everyone truly cares about privacy. And that's a point that really matters. And the third point is obviously that, all these data can readily be collected these days, whether it's through mobile and IoT devices or inferred using AI and machine learning algorithms. So hopefully you're convinced and you sort of try to play this very quickly in your head as I was quickly walking you through these scenarios that I like to spend a bit more time on with people when I have more time available. So what is privacy? I could, at least spend an hour talking about privacy, but it's an evolving set of expectations and concepts and rights. And this goes back to centuries ago, where people started to recognize the fact that people probably have some kind of fundamental right to life and some fundamental right to property. And over the years, these rights have evolved, where the right to just remain alive has extended to the right to enjoy life, which has included, for instance, if you go back a century ago, the right, for instance, to say, hey, that train track that passes next to my home that wasn't there when I bought my home, that's extremely annoying. That's a violation of my privacy, the smoke, all these sorts of things, but also protection of your reputation, slander, libel, and eventually also looking at property as extending to intangible assets, including data about yourself. And so this is an evolving collection of rights, truly. But for the sake of this presentation, first of all, let's just quickly go over a couple of definitions of privacy, which is a very, very broad concept, as I think I've already shown you. So this was defined in 1890 as the right to be let alone, free from surveillance or interference from other individuals or organizations, including the state. More recent modern definitions are basically the right and ability of an individual to define and live his or her life in a self-determined fashion. You might say, okay, what does this have to do with anything? We're talking about generative AI here. Well, we're going to focus more specifically on information privacy in a minute. But just moving along, and so that you appreciate, where privacy comes from. It's enshrined these days in a variety of different documents. The UN Universal Declaration of Human Rights back in 1948, or US Bill of Rights with the first 10 amendments to the Constitution. Nearly every amendment in the Bill of Rights has a privacy dimension, starting with the First Amendment, freedom of speech, freedom of opinion, freedom of assembly, and so on. The Fourth Amendment is one that's often referred to. It's about warrantless search and seizure, the right for people to retain some privacy in their home, in their private papers, and so on. And obviously, there are many more specific laws that have emerged over the years. So, for instance, children with COPPA, FERPA, for those of you obviously in education, in education, that has to do with the protection of data about students. Gramm-Leach-Bliley. This is a session about financial apps and services. So Gramm-Leach-Bliley is the Financial Modernization Act, which has some privacy provisions, HIPAA for health, but also state laws like California, CCPA, CPRA, and a variety of different laws around the world. Often you hear, for instance, about GDPR, which is a law that has had a very major impact around the world over the past 5 years. So for the purpose of AI and information privacy, we're going to focus primarily on what people call information privacy. And ultimately, to keep it simple, this has to do with the ability of individuals to retain some control over the collection and use of their information. And so in practice, this has been implemented through a framework that people often refer to as notice and choice, which is basically the idea that there should be some kind of a privacy policy that's going to state what you do, what data you collect, how you use it, and all sorts of other things. And you're going to also try to give people some control over what happens to their data, some choices, such as perhaps the ability to opt in to some practices or opt out of some practices, or additional types of control, which we don't necessarily have the time to delve into in much detail. But from a practical standpoint, as you work on AI and generative AI technologies, you need to know a few things. And you need to know in particular that over the past 5 years, there's been a bunch of new regulations that have been introduced. These regulations are much more stringent in terms of what you need to disclose in your privacy policy. And they're much more stringent also in terms of the rights and controls that data subjects, namely those people whose data you're collecting, need to be provided with. Not just necessarily opting in or opting out of some practices, but also the ability to review data collected about them, delete that data, object to automated processing, which is something that you have, for instance, in EU privacy laws, GDPR, General Data Protection Regulation, and a variety of other expectations. Along with these expectations, much steeper penalties have been introduced, right? So the biggest fine in this space remains the $5 billion fine that Facebook was basically slapped with by the FTC here in the United States. But if you look at all sorts of other fines over the past few years, they get very steep, hundreds of millions of dollars sometimes. And don't think that you just need to be Amazon or Google or Facebook to get under the scrutiny of these regulatory agencies. The small players have also been slapped with very severe fines, and so that's not something that you can ignore. And so I wanted to sort of make that very clear. But now let me slowly get to the point of how can AI help with privacy. And so I've mentioned this concept of notice and choice, the idea that you're going to have a privacy policy and that people are going to read this privacy policy, and then they might be able to exercise some choices depending on whether they like or they don't like some of the things you said you're going to do in terms of data you collect and how you use that data. So number one, nobody reads these privacy policies. I'm not even going to bother doing a show of hands here. I know what the outcome will be. So it's been said that only in Fantasyland do people read privacy policies. And one of the consequences of the new regulations that have been introduced over the past few years is that these privacy policies have actually become even longer, perhaps about 25% longer. So if nobody was reading them 5 years ago, what are the chances they're reading them today? And, especially if you're thinking about reading those policies on cell phones. And all these great controls that we're giving to people to restore agency and the ability for people to really, be in charge of, in control of what happens to their data. Just look at your cell phone and the number of different settings that you have. For instance, just when it comes to the privacy of your mobile apps. And I've published this, some years ago, a typical user with, between 50 and 100 apps would have to configure manually somewhere like around 200 different permission settings to actually, be fully in control. So who's got the time to do that? And so at the end of the day, all these regulations are great, except that they're highly unrealistic about what they're expecting people to do in terms of expertise, whether they actually understand the choice available to them, the data practices, the implications of agreeing to certain types of practices. People often also lack the attention and the motivation because, as it turns out, privacy is always a secondary task. And what that means is that typically privacy decisions that you have to make arise in a context where something else is your primary task, such as downloading that game app on your cell phone and starting to be able to play with that app, right? That's your primary task. And the privacy decisions that you make along the way, those are things that your brain will tend to dismiss because they're secondary tasks. Your brain will tend to, basically decide that, hey, I shouldn't be too bothered about this. The consequences are highly uncertain. Let's not worry too much about that. And so a lot of my work in this space over the years has really been to ask, how can AI help people manage their privacy? So if they don't read privacy policies, could we read these policies for them? For instance, if they don't have the time to configure all these settings, could we help them configure those settings? And those are examples of things that we've been doing. And along the way, we've also done a lot of work in the area. So I'm co-director of the privacy engineering program here at CMU. And that includes doing a lot of AI governance also these days. And that means helping organizations develop more systematic practices that will ensure that they take privacy into account and they take into account risks that are associated with using AI as they design their products from the very beginning. And so there are all sorts of different things that need to be done within that space if you want to do things right. And so a lot of my work in terms of helping users has revolved around the use and development of what we call privacy assistants. And those assistants are designed to help people understand practices that matter to them without requiring them to read the entire text of policies, helping people configure, for instance, settings as far as what data their mobile apps can access, nudging people to pay more attention to those decisions that they tend to dismiss because privacy is a secondary task, as I mentioned, and all sorts of other things that I don't have the time to talk about. So examples of things that we've done, for instance, and I'll go very quickly here, include, and we've been doing this sort of work for about 12 years now. We've been looking, for instance, at the text of privacy policies and automatically extract opt-out choices that were traditionally buried very deep in the text of these policies, and therefore choices that people were never really aware of and would never take advantage of. So we've built, for instance, browser extensions that are available in the Google Chrome store for people to add to their Chrome browser, and that basically make these choices much more readily accessible. We've built assistance to help people configure their privacy settings in their cell phones using machine learning techniques to try to understand how groups of like-minded users can be identified and how, based on how you feel about a few small number of issues, we can basically recommend a variety of different settings for you. Nudges, those are technologies, by the way, that have actually been introduced in versions of iOS over the years, like iOS 13 has introduced nudges like the one that you see here. Did you know that your location has been shared 5,398 times with Facebook, Groupon, and Go Launcher over the past 14 days? I can tell you that when you show that to someone, even though traditionally they may have been ignoring privacy, you show them that and all of a sudden they want to know more and they may want to modify a number of their settings. And then privacy question answering, which is the closest to generative AI. But before getting to generative AI, just to give you a sense for what else you can do when you look at, for instance, the text of privacy policies, is you can look at all the statements that a company makes in its privacy policy, and then you can say, hey, let's compare that with what, for instance, this app actually does. And so, for instance, if you analyze the code of an app, or if you look at the behavior of an app, static or dynamic code analysis, and you compare what you see with what the company might be saying in its privacy policy, you often find a bunch of discrepancies. These discrepancies are what will get you in trouble. This is how the regulators will come after you and say, hey, this is misleading. We're going to slap you with a 10, 20, $30 million fine because you've been saying certain things, but the behavior of your code is entirely different. And so just to give you a sense for how severe the situation is in this space, we actually analyzed at some point back in 2018, over 1 million Android apps on the Google Play Store. And we found that on average, there was about 3.47 potential compliance issues per app. Over 600,000 apps had compliance issues. So this also gives you a sense for how challenging privacy is for your regular developers, and that obviously extends to people working in generative AI. So most recently, we've said, well, if people are not going to read the text of privacy policies, right, could we potentially just, allow them to ask whatever question is on their mind, look at the text of the privacy policy and perhaps other things, and then, automatically answer their questions. And so examples of typical questions, we've collected very large corpora of questions, include things such as, does this app share my location with advertisers? Which is a pretty simple question. But also, should I be concerned that this app shares my location with, let's say, analytics companies? And some number of these questions these days, thanks to some research we've done also over the past 10 years, are directly addressed now in what people call privacy labels. You might have seen these in the App Store. But about 50% of the questions people have are not addressed by these labels. And these labels, honestly, are already way too complex, and most people are not even looking at them. And so we've asked ourselves, how could we potentially, answer these questions so people don't have to read policies, they don't have to look at the labels, let them ask what's on their mind and see if you can answer these questions. And so we've played with, ChatGPT, we've played with a variety of LLMs over the years, and there are a number of challenges that need to be addressed. So my talk here is not about like we've solved all these problems and it's done. It's more about, here are some of the things we're doing, and here's roughly where we are. So for instance, issues that you have to deal with when you read the text of a privacy policy is that the policy might be referring to your GPS data being collected. And then you've got to obviously make the connection that, hey, GPS data is, for instance, a subclass of location data. But there are also much more subtle types of inferences that you need to make. So for instance, if a policy says, we ask you to tell us how you go to work and whether you're driving or biking or walking, as it turns out, this information can also be used to make inferences about your health, whether or not you exercise, right? And then beyond that, and this is one huge challenge that ChatGPT is terrible with, right, is the fact that because privacy policies are written by lawyers, lawyers in general will work very hard at not telling you things they don't have to tell you. And so there's a lot of silence about questions that people have in the text of privacy policies. And the question is, how do you interpret that silence? What sort of inferences can you make about that? And so depending on the regulation that's relevant to the situation of a given person, there might be regulations that say, if you do this, you've got to disclose it. And there are other places like Pennsylvania, where most of the time you can do things, and as long as you don't disclose that you don't do them, it's actually okay. And so we look, for instance, at typical questions that people have, like, does this app share my credit card information? And about 16% of the time, right, the text of the privacy policy will not tell you. It's going to be silent about that issue. Or 50% of the time, the answer will really be only implicit. And so the challenges that we've got to deal with within that context are, how do we interpret silence, given what regulations require you to disclose, and how do we turn all that into a meaningful answer for users? And we've actually had some success at representing this knowledge and then adding this as an extra layer on top of ChatGPT and similar types of solutions. So I'm going to quickly wrap up because I feel that I'm probably running out of time. I see Caroline starting to get perhaps a bit nervous, or she's doing a very good job at not pretending that she is. But the most recent work that we've been doing in this space has been looking also at how do we produce personalized answers for people. So answering even these privacy questions, as it turns out, you can come up with generic answers, but that's not terribly valuable. You want to adapt to what your user knows. This includes, for instance, the age of your user, their gender, as it turns out, attitudes towards risks. So does the user actually realize that, you know, if they agree to this practice, they're exposing themselves to all these potential risks, or do I need to potentially let them know? And beyond just answering questions, could we somehow proactively tell people that, hey, you forgot to ask me this question, but you probably want to know about this stuff. And how do we use generative AI for that? And so there are all sorts of challenges I don't have the time to talk about in this space. But one reason why this is so challenging is that answering the same question in different ways has a very different impact on what people will understand and how they're going to respond. And I don't have the time to go over these various colors, but this is about 9 different ways of telling people that their location is being shared, and how, depending on how you frame this answer, people will respond very differently in terms of whether or not they're going to grant access to their location or not for that purpose. So let me wrap up. So first of all, and this is something that perhaps I've not emphasized enough, there's an interesting clash of cultures between privacy and AI, right? So the traditional culture in AI, and I'm an AI person, right? So my major when I did my PhD many years ago here in computer science at CMU was actually AI. But, you know, traditionally in the machine learning community, the approach has been collect as much data as you can from whatever source you can find and mine it to death, right? And privacy says exactly the opposite. Privacy says data is a liability. Don't collect more data than you need. Don't keep it for longer than you need. Use it only for the purpose for which you obtain consent to collect it. All these types of issues are completely foreign to your typical AI person. And so one of the fun things that I do in privacy engineering and in lectures like this is to try to get people to be more aware of these differences. And these challenges extend to issues of fairness and transparency and equity and justice, which are all falling under privacy, in case you don't realize. I don't have the time to go into much detail here. And there are obviously unique challenges associated with generative AI. I don't have a ton of time to talk about these things, but many of these things have made headlines over the past few months, right? Such as, you know, this law professor who, you know, was falsely accused of sexual harassment. That sort of made the headlines at some point. So libel and slander, when you're dealing with technologies that make up facts, right, that exposes you to all sorts of potential risks. And so you want to think very, very carefully about this. And those risks, you know, might be, you know, those misrepresentations might be intentional, right? So we had someone talk about phishing attacks earlier and deep fakes, obviously. So that's the worst case scenario. But also if they're non-intentional, you still have a liability, right, for what your technology might say that could potentially, you know, affect the reputation of someone. Training, you know, all these models with confidential data. How do you make sure that data doesn't get released later on? Bias, right? So that bias is present everywhere. We see this all the time. This summer, for instance, I had an undergrad working with me on generating answers to everyday cybersecurity questions that people have. And we played with different personas using prompt engineering. Major bias between, you know, whether ChatGPT believes the question comes from a female or a male, right? Why? I have no idea. But the answers for female users tend to be better, as it turns out. They're more detailed. Impossible to fully validate these models. I think we all realize that. Issues of transparency, which are actually required for privacy reasons, are very, very elusive. And there are all sorts of other things I don't have the time to talk about. But hopefully this was interesting, and hopefully you feel that you've learned something. And thank you for the time, and apologies for exceeding my time, Caroline.
Thank you so much. This was extremely interesting and on point. And of course, privacy concerns have been huge in this space. And you have really done a great job of outlining the tension between AI and privacy. There were a couple of questions in the chat, and I think they have a common underlying theme. And even though we're a little bit over time, I'll just kind of reframe the set of them into maybe one question. You've already shown that even before these recent advances in generative AI, there were already many ways that you were using artificial intelligence to improve awareness to privacy issues and to get people to really actively engage with their privacy settings. So the question is, you've talked a little bit about things that could be done with generative AI in this space that possibly go beyond what was being done before. But what do you think is the most different thing, the place where you can have impact with the recent advances that wasn't possible before?
Yes.
Or would you say that it actually is just more of the same?
No, I think that, the capabilities of generative AI are pretty amazing in terms of, really being able to generate text that people will be able to relate to. And I think that's extremely powerful. What we need to work on is, sort of harnessing this in an environment where you don't mislead people, where, where this becomes beneficial. And so a lot of my work, for instance, over the summer with some students was just using prompt engineering to try and see whether you could actually get these answers to really, motivate people to pay attention, to explain the risk to them, to avoid obviously giving them misleading answers and those kinds of things. So that's extremely powerful. I have to say that I'm a bit of an iconoclast in the space of privacy. I started telling people more than 15 years ago that, hey, you know what? AI has actually a big role to play in privacy. And the reason why, and now people are buying this, and they're all coming to me for talks and all these things, and they've come to realize that all these regulations they've passed, which are great steps in the right direction, are just amounting to nothing at the end, because they're making these highly unrealistic expectations about people, like these longer privacy policies. This is wonderful, but nobody reads the stuff. All these controls, that's great, but nobody engages with these things. And so you need that extra layer of functionality, and that's what AI is all about. So we really need AI to actually make privacy practical. And, it took me a long time to get people to see that. But now they've come to realize, people are just saying, okay, this notice and choice paradigm has completely failed, right? We need something new. And this is where I'm now able to tell them, look, I've actually been doing this stuff for a number of years. Look at what we've been able to accomplish. And I'm actually getting a lot of attention right now, including from regulators who are saying, maybe that's the way to go. And it's still very challenging, because it's very easy. You cannot guarantee 100% accuracy. So how do you evaluate this stuff? And my point has been, for instance, to help people configure settings on their cell phones. How do you, advocate using AI to help them do that? Well, one thing you certainly don't want to do is do it automatically for people. That is going completely against the concept of privacy, which includes this notion of agency. I have to be in control of my data. Right? But what you can do is you can try to make recommendations to people and enable them to take advantage of these recommendations, that are becoming more productive, and they're able to actually configure their settings much more efficiently than they would be otherwise. And so the criterion I've been arguing with people is that at the end of the day, you've got to ask yourself, does the user have a greater number of settings that are aligned with their preferences, with or without this technology? And it's very clear, for instance, in the case of recommending settings to users, that they're much, much better off with this technology. And we've done pilots with real users on real cell phones, and it worked super well.
Yeah, and there's a great discussion in the chat, and I'll be combing the chat for comments to pass on to the speakers after the fact, so that they get to benefit from all of that. Let's thank our speakers once again. Thank you, Norman. Thank you, Tianqi. These were very inspiring. Also, thank you, Anusha and Siddharth, and all of the teams. And please come back tomorrow for the judging event, where you'll get to see how the team projects ended up and participate in the judging. And even more than that, please come on the 11th for our closing session, where you'll get to see a talk from each of the winning teams and 2 great closing keynotes, one by Jamie Teven from Microsoft, and the other, our new department head, Mona Diab. Okay, thank you so much, and have a great Saturday. Bye.